I'm reaching for anything. Ask again, please.
Like the Z-chart in Excel has slightly different decimals?
Yes, that's right, because the Z-chart rounds, you can only use 2 decimals to the right, and so it ends up rounding your answer, estimate. But this will be more accurate because we're using 4 digits to the right. But if you even use more digits, it's even that much more accurate.
Would this give you the same exact like decimal as if you did like the full equation from Excel?
Say it one more time, sorry.
Would this give you the same exact answer as if you did like the full equation
No,
from Excel?
no. Only if you did every single digit out would it give you the exact same answer. This is the most accurate one of all, where it's doing the whole thing for you, where you gotta enter all 4 numbers. That one's way more accurate.
Okay.
That's the more exact one. And then if you take your Excel spreadsheet and you could go out 10 digits, you would even be more accurate. So you have to spread that whole column up till you get that many digits. So yeah, that would be the more accurate one. This one's still estimating, depending on how many digits you use. That's why I'm asking for at least 4 to the right, because it's still estimating. What didn't work? What didn't work? This?
Yeah.
What? Okay, you put equals, norm, S, check real quick, DIST, parentheses, you put 1.0909,
Yeah.
and you got a probability, point what?
It's telling me in there.
Oh, stop. You got it, because you got your equal sign, maybe.
I did.
Here we go, let's try it. I'm gonna do it right here. Equals, NORMSDIST. Is that where we're at, right? Parentheses, 1 point, am I still going? What did I do wrong?
You didn't put parentheses.
Oh, I put the wrong parentheses. Oh. Okay, so parentheses, 1.0909, parentheses, right? Is everybody with me? Is this how you type it in? With the S, right? So we should get a probability. I'm trying to look at it. Let's see, 266. Okay, I'm using right now in my mind, I'm using the empirical rule. I can see 266 is to the right at 254. And look, it's to the right by almost exactly 1 standard deviation. Think about the empirical rule. 1 standard deviation to the right of the center, so we know it's 50% plus probably that one little section there, right? We're darn close to being exactly that one section. So the answer should be around, I can't remember, 80 something percent, right? 0.8 something, here we go, see? 0.862342. With the empirical rule figured out, you can know if you're doing it right or not by being able to just estimate what the answer should be. That's why we started out with that bell curve for 3 weeks in a row. So you'll know you're doing it right that way. All right, so what'd you do wrong? Did you figure out why it wouldn't work?
I don't think so.
Let me look at it after class. It could be just the equal sign in front.
It seems to not work with the dots in it.
When you put the dots in, let's do it again with the dots. Hang on. Hang on, I'm gonna do it right now. I'm putting a dot on one side of the S. I'm gonna put a dot on the other side of the S. Now let me review it. Equals norm dot S dot DIST parentheses 1.0909 parentheses. You're saying this may not work, you're saying?
Yeah.
Let's see what happens. Oh, you gotta be kidding me. Stop. What is going on here?
Oh, because that one wants a cumulative.
Oh, I forgot, comma 1. If you're using the dot, you gotta put a second comma 1, just like you have to do with norm distribution, the 1 on the end. I forgot, hang on, here we go.
That's last two.
There it is, there it is. I forgot there's 2 numbers when using the dot. 2 numbers, but the second number will always be a 1. Always, we're using normal probability, so it will always be a 1. There's almost no reason to have that there. You don't have to use the dots. It's up to you whether you want to use dots or not. Well, I apologize, because if you decide to use the dots now, you got to remember to put that second number, comma 1. If you're going to use the dots, you got to put a comma 1, just like that. So now we replaced the Z-chart from this point on with norm S distribution. And when it comes to using the Z-chart, this is our go-to, norm S. So from this spreadsheet I posted last week and this week, we've learned now the norm S that's at the top. We've learned normal distribution, which is here in the middle, and I think we're 1 or 2 weeks away from learning norm IMV, but we're heading there to learn that one. So this spreadsheet will be up there again on Canvas. But right now it's all about norm S. All right, what's next on my list here? Let's go to week 5 instructions. Whoop, there's the in-class, I didn't go over everything. There it is, week 5. We have 2 assignments due this week, the written assignment and the Excel assignment. Due a week from today, February 13th, on Tuesday the 13th. We're using both Chapter 1 and Chapter 2 PowerPoints. The reason we're going back to Chapter 1 and 2 PowerPoints, this is what we've learned so far. Variance, standard deviation, expected value, mean, median, mode, frequency, relative frequency, percent frequency, bell curve, z-calculation, z-chart, binomial probability, normal probability, empirical rule. These were the building blocks. We're doing this so different from the other classes. They start out with Chapter 1, Chapter 2 PowerPoints, the things we're about to learn. I jumped into the things that I felt mean the most when it comes to understanding statistics, especially that bell curve. Where's that at? Especially that bell curve, understanding that with that empirical rule helps you see the big picture of how this all calculates out and really how easy it is. That's really, all this stuff is really easy. It's just a matter of breaking it down into these little steps. But now we gotta go back and learn these things: cross-sectional, time series, experimental versus observational, bar graph, histogram, pie chart, dot plot. We gotta learn those because we skipped them, but we need to learn them, but they're not nearly as important as what we learned. These are really important. This was the building block that's gonna carry you through this semester right here. As if you understand these things, you're gonna be okay. But this stuff, yeah, you're gonna have some multiple choice questions on it coming up. So anyway, your homework's due in a week. I do wanna point out, this week's homework's a little weird compared to normal because, look, it's from the textbook. And I know some of you are trying to get away with no textbook possibly, even though the textbook, I saw it was less than $20 on some web pages. So I don't know why this class would be the one you go without. It's the $200 book you need to go without. That's the one. But anyway, here's the problems. I posted a picture of pages 40 and 41 so that in case you don't have a book, you can still look these problems up. Or if you're using an older version, you can at least look up and see if the words or numbers have changed from one edition to the other. So if you have an old edition, maybe at least look at this picture to see if the numbers have changed or not. And I don't think they have, because last semester we did the same, most of these anyway. So I want to talk about this. This is old stuff. This is relative frequency tables, percent frequency tables. Remember that from week 1? This is old stuff, so you're going to find it easy, but we got to get it out of the way. So let me see what's the homework say we got to do here. Numbers, whoop, 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 let me scroll up. Oh, shoot, hang on, where is it? Right here. Numbers 1A and B, 2A, 3A, 4A, 5A. So number 1, A and B, let's look at that. Let me see if I can zoom this in more. Number 1 says, 50 pro football rookies. Can barely see it, can you? Let me get it bigger. 50 pro football rookies were rated on a scale from 1 to 5. So here's the rating. Here's all 50 of them. If you add this up, that's 50 of them. And A and B says, A, how many of the rookies received a rating of 4 or better? It's obvious what the answer is. How many received a 4 or better? But you got to show me what you're doing in your mind. We're back on chapter 1, you guys. So you're going to go, why am I writing this out? We just got to get it out. Show me what numbers you're adding together in your head. Write it down to get this answer. So how many rookies are rated 4 or more? There's 2 of the numbers you're adding together. Show me. How many rookies received a rating of 2 or worse? Show me which numbers you're adding together to get that one. B, construct a relative frequency table. What proportion received a rating of 5? So you're going to have to take each of these numbers, show the work. 4 divided by the total, 10 divided by the total. Show me that work in each calculation, what the answer is. Then highlight whatever one calculates out for rating 5. Once you get down to number 5, you're going to show the work, 4 divided by something. You're going to get a result, then circle it and put an arrow or highlight it that shows me that's the answer to part B. But
Can you repeat that again?
okay, you ready? B says construct a relative frequency table. To do that, you got to show your work. 4 divided by some number, 10 divided by some number, 14, and all those answers. Then it also says what proportion received a rating of 5. Which calculation was for 5, a rating of 5? So when you take 4 divided by some number, and whatever that result is the answer it's looking for. And that's the one you circle, and that's the one you put an arrow, that's the one you highlight, somehow letting me know that's part of the answer for B. What's proportion? Proportion means point something or percentage. What percentage received a rating of 5? And that's, you're gonna show me all 5 calculations, but it's that last one that you're gonna circle and say, this is the answer. Everybody get it? Yes.
What are you dividing? You said by some.
I don't wanna give away the whole problem, so I didn't wanna tell you what you divide by.
Oh, okay.
So I keep saying you gotta divide by this, you gotta divide by this. But I'll give you a hint, they're all divided by the same number.
I got it.
Did you have it? Well, then what's the number? Well, no, not the mean. The total. The total, you gotta divide each of them by the total. That's that same question?
No, I was gonna say the number.
Oh, thank you. Okay, what's the next one on the assignment? I didn't wanna do the whole assignment, you guys. I just wanna point out, I didn't want you to be confused, because you could get it done early. So 2A, 3A, 4A, so 2, 3, 4, 5, but only A on each one, so let's go through them. 2, the following frequency distribution table shows sales of men's shirts on an online retailer for the weekend. Small, medium, large, extra large, there's how many. I'm sure this is gonna say, convert this to a relative frequency table. Again, show me the work. 80 divided by some number. I'm not gonna give the number away. 175 divided by a number, 210 divided by, show me that work in each calculation, then answer the question for A, which is, where's A? Construct a relative frequency table, just like I said it's gonna say. What proportion of sales were for the medium-sized shirt? So that calculation for medium is the one you're gonna circle or highlight or put an arrow. That's answering the question, but you're gonna show all the calculations, but that's the one you're circling, the one for medium. Okay? Everybody see number 2. Number 3, just A. Construct a relative frequency table. What's the proportion of purchases occurring on Wednesday? You're gonna take each one of these numbers divided by 2504 divided by something, 2880 divided by something, and give each result, but then go up to Wednesday, circle that particular answer, highlight it, or put an arrow to show me that Wednesday's is the one you're answering the question with. Everybody get it? All right, number 4. Wait, where's the question for 4? Up here? 4A says, construct a relative frequency table. It's almost getting redundant now, right? And to construct that table, someone tell me, what do you guys do with this 6373? Divided by what?
Total.
Some number. That's right. Okay, we're on the same page. 7647 divided by some number. 16,609. Show me that work, but you're going to circle one of these. Let's see which one you got to circle. Construct a relative frequency table. What proportion of people who live below the poverty level live in Midwest? So you would end up circling the one from Midwest. That one right there. You're going to highlight or circle. So too easy, right? But there's one more. Now it gets tricky. This one's already a relative frequency table. Let me repeat that. This one's already a relative frequency table. It's asking you to convert it to a frequency table. We're doing it backwards. Does anybody need a hint?
Yes.
Oh, you do? Seriously? I didn't expect that response. Hang on. Let me stare at it for a second. The hint is in the first sentence of the problem. I'll read it. A recent poll of 3,057 individuals asked, I'm going to stop right there. That's the hint.
Oh, okay.
Everybody, you with me? Do you need any more hints? Yes? Are you serious? Okay, it says 3,057. A says construct a frequency distribution table. But you have relative frequencies, so you gotta say to yourself, how did those 0.21, 0.18, 0.36, how did they come about? You just got done constructing 4 others, so you know how they came about, and you have what the total is, 3,000, what is it? 3,057, so think about it. You gotta take that 3,057 and those 0.21, 0.18, and so on, and do something with them, each of them, and show me the work. But then circle one of them that answer this question. What's the question? How many people are going to take 1 week vacation? So you're gonna, right there, the 1 week one, show your work and circle that one. That's the one you gotta circle or highlight or put an arrow. Show me that's the question you're answering, A. That's it for the homework, right? There's a number 6, is there? Let me look. You guys are scaring me with that look. No, 1, 2, 3, 4, 5. So just the first 5, and just A's for the 2 through 5, and 1's the only one you got A and B. How do we feel? Can we do the written part of the homework even before Thursday if we wanted to? Because it's almost like review, isn't it? Okay, good. All right, so we got that. Now we gotta learn some other stuff. Some other junk. What? Junk. Wait, before we do that. Oh, no, we're recording now. All right, let's keep going. Whoop. Okay, here we go. Where am I going here? I'm gonna go to, well, let me mention these. These are different types of data that get collected. Nominal, ordinal, interval, and racial. Yes, you should understand those to be prepared for DS 302. But I'm jumping up past those to qualitative versus quantitative. Qualitative versus quantitative. And let me put some data up here. 12, 13, 21, 09, 32. There's data, right? Just numbers. Those numbers represent just numbers. They represent what you see, 9, 12, 13. That is quantitative data, not qualitative, quantitative, because it's just numbers that mean just numbers. They don't really have any other meaning than themselves. Okay, but let me try this now. What if I did this and I say 1 equals no pets, 2 equals dog, 3 equals cat, 4 equals both. Now you're collecting data. Hey, we're collecting, we want to know if you have a cat or a dog or and how many or something like that. And they say, oh, we don't have either one. You're going to put a 1 down for them. No pets. No dog or cats, what I meant to put there. Call the next one. Hey, do you have a dog or a cat? And they say, oh, we have both. You're going to put a 4 down. You're using numbers again, but the numbers represent words. No pets, dog, cat, both. That is qualitative data. Sometimes called categorical, which is what I almost said. Qualitative data, also called categorical. It could also be numbers, just like quantitative data, but the numbers have meaning in words, that they're representing words. Now let's say there were no numbers there, that we're literally writing down the words no pet, dog, cat, both dog, cat. We're collecting that data. That is also qualitative data because we're collecting words. So if we're collecting words, you know it's qualitative, and if we're collecting numbers that represent words, you know it's qualitative. And if we're collecting numbers that don't represent anything but themselves, numbers, that's quantitative. Okay? Now listen. We're going to sit out front. We're going to sit out front, and we're going to meet there on Tuesdays, right after class. So what time we get in? 10:45, everybody, we're meeting out front, and we're going to count the car, we're going to count what color the cars are that are going by. We're going to have a whole list of colors, and we're going to mark a 1 down if it's red, a 2 down if it's blue, a 3 if it's white, and so on. My question for you, what kind of data did we just collect? Qualitative or quantitative?
Qualitative.
Very good, because the numbers represent words. Very good. Now, we're sitting out front again. We're doing a second experiment. All right, we did it after class. We're counting how many cars go by from what time we get out of here? 10:45 to 11:45, and we're going to do it 5 days in a row to find the average for each day. Or are we collecting qualitative or quantitative data? Quantitative, because we're only counting how many cars. The numbers we're writing down on how many cars only represent how many cars. They're not representing what color the car is, and not representing anything else other than numbers.
So if we have just like the words, so like no pets, dog, cat, both. is
That's
that-
qualitative. Qualitative if you have just the words. So, what slide is that little chart on? There you go. Qualitative data is using continuous and discrete data being collected. Number of children, you're collecting the number of children. Hey, how many children live in your household? There's 3 or 2 or 1. Well, there's no way they're gonna say we have 2.5 kids, we have 1 kid that only has half a body. It's not gonna happen. You're collecting discrete data. There's 2 kids, there's 1 kid, there's 0 kid. And the numbers have no meaning other than how many kids. They're just numbers. So you know it's qualitative, or quantitative, excuse me, quantitative. Same with when you're collecting continuous data. Hi, we're collecting the height or the voltage. I'm calling electric companies, and we're collecting the voltage at your location. What's the voltage? What's the voltage? Or whatever it may be. We're gonna get 2.3 volts, 13.6 volts. We're getting numbers that have numbers on the right side of the decimal. That's continuous data, and it's also collecting those numbers which represent the number of volts. They represent numbers. So that's still quantitative data. Qualitative data is called categorical data. Things like marital status. Hey, we're calling to see what your marital status is, and you give them the options: divorced, single, widowed, blah, blah, blah. They tell you, you write it down. You're collecting words that have meanings. That's qualitative data. Or you're putting a 1 down because they said divorce. You put a 2 down because they said single. You put a 3 down because they said widowed, something like that. The numbers represent words. It's still qualitative data we're collecting. So my question for you is, if I describe some data, you're gonna have a multiple choice. Is the data I just described qualitative or quantitative? Can you recognize it?
Yes.
You think so? Everyone?
For quantitative, you said it was this one.
Quantitative is this side over here, which is where we're collecting numbers. Always will be numbers, and the numbers have no real meaning other than the numbers, how many of something, or how much. Qualitative versus quantitative was what that was all about. Where's that at? Where's qualitative? It's not even on here? Jeez, I'm falling apart. Qualitative versus quantitative.
What was the other word for qualitative?
Qualitative, sometimes the word is categorical, which you can see on the left here.
Gotcha.
Categorical, because you're using words. Categorical means you're using words that have categories. Single's a category, divorce, things like that. All right, so we got that definition down. Now, we gotta go to right here. Cross-sectional data. I need you to understand the difference between cross-sectional data and time series data. So if you have a question related to this, it might be, here's some data being described to you. Are we collecting cross-sectional data or time series data? Are you ready? If the data being collected is during the same period of time, but we're collecting it from different places or different kinds of data, but it's the same period of time, that's called cross-sectional. I'll repeat that. We're collecting data from the same period of time, that's cross-sectional. Here's the example. Data detailing the number of building permits issued in June of 2007 from each county in Ohio. So we would go to each county and say how many building permits were issued in June of 2007. And we collect that. There's probably 120 counties. We collect 120 pieces of data on how many building permits. But the thing is, every piece of data we collected was from June of 2007, the same point in time. That's why it's cross-sectional. The same point in time. All right. Time series is where you're collecting data from different points of time, but in a series. Different points of time, but in a series. So time series would be data detailing the number of building permits issued in Lucas County, Ohio, each of the last 36 months. There's the time series. We want the number of permits for the last 36 months in a row, different time periods, and they're in a series of 36 in a row. That's time series data collecting. Notice we didn't say, hey, we want month number 36 from each county. That would be the same period of time, then that'd be cross-sectional, exactly. This is asking for the data from 36 different periods of time, and they happen to be a series of time that are in a row. That's what makes this time series data collection. Okay, so you think you can recognize it, because that would be like a multiple choice question. Hey, you're collecting the permits from Lucas County, Ohio for the last 36 months. Are you collecting cross-sectional data or time series data, A or B? That's the kind of question you should expect. All right, let's go to the next one. Where is it? Did I skip it? Oh, here we go. Collecting data by using experimental studies, compared to collecting data using what's called observational non-experimental studies. Both are very common. Everybody's heard of those research experiments where, let's say they're trying to figure out if a brand new drug, a pharmacy's come up with this new drug, and they have a group of people who are really taking the drug, and a group of people who think they're taking the drug, but they're taking what's called a placebo, a fake drug, which really is not the drug. Maybe it's just even sugar or something normal. Well, that's called experimental research. You're doing an experiment, you have what's called a control group, and you're collecting data to see what there's certain things you're collecting from each group, and you're comparing them to see if they're different from each other. It could be white blood cell count. It could be anything in the blood. There's all these different statistics from the blood that maybe you're measuring. And you're testing to see if the group who are really taking the pill have different stats of this data you're collecting compared to the group that thinks they're taking the pill, they really aren't. And if there isn't that much of a difference between them, you've proven that this new pharmaceutical drug really is not having the type of effect that the drug company says it's having. But if there's a very significant difference between the two groups, then the only difference between the two groups is that this group's taking the real drug, and that you're proving then that must be what's causing that difference. The results that you actually want to get is so different from the other group who think they're taking the drug, but they're not. That's experimental studied research. And the statistics is applied to the data you're collecting from the two groups to see if they're different or not different. And I want to tell you on a bell curve. On a bell curve, the closer to the center of the two data are, when you subtract the two, means they weren't very different. But when you subtract the two, if they're at one end of the bell curve or the other, you're proving that drug caused the two stats to be that far different from each other. You're applying statistics to prove that they're that far different. That's experimental research. Observational is more common for students who are, for example, working on their master's degree. Now, a lot of you are considering working on your master's, maybe, and some of you are saying, no way, once I get my bachelor's, I want to go out and make money. But once you're out there making money, you're going to go, God, I can make a lot more money if I got my master's. That's what happened to me. And then I did it on weekends. Kept my work full time, did my master's on the weekends, because once you get that master's, boom, you're open for more promotions that were not an opportunity to you without the master's. I eventually became president of a company because I had my master's. So what happens is most master's programs, like way over 90% of them, have to do what's called a thesis, which is most people use what's called observational research study to do a thesis with. Kind of a mini research project. Well, I say mini, but most of them are almost 100 pages when you put it all together. So it's not really all that many. But for a master's program, you're supposed to prove that you can apply statistics to some kind of research. And the most common, because it's not that expensive, to do what's called observational research. Now I'm going to give you an example. A colleague of mine was working on her doctorate, and she did an observational research project where she asked several of the faculty if they would record themselves while they're giving a lecture. And then everybody had an hour recording. Now this was an audio recording, by the way. It wasn't video recording. This was a long time ago, before iPhones were invented. But this audio recording, then the grad, she was working on her doctorate, she would listen to them. She did it with like 30 faculty and count how many pauses, or using the word like, or some kind of annoying speech that makes it kind of annoying for an audience to listen to. She counts them. Then she asked all 30 of us to do this online training. We went through this all training program, and then a little bit after the training, she asked us all to record our lecture again. So we had to record our lecture again. Now, she goes back and counts the new recordings, how many of those annoying things there are after the training took place. And then uses statistics to see if the average amount of annoyances before the training are significantly different from the average amount of annoyances after the training. If the training had no effect, those two being subtracted from each other will be darn close to zero. It'll be kind of in the middle of a bell curve. But if the training had a real effect, the average amount of annoyances should be far less in the group after the training, right? Because they're trained to not do those pauses or like this, like that, or whatever the annoyances are that they were being counted. There should be less. So when you subtract the two, there'll be such a difference that it will calculate out to the outside of the bell curve. And if it's far enough in the tail of the bell curve, your project proves that training had an effect. There's so far less of those annoyances in the group after they went through the training compared to the group before the training, that it had to be the training that caused that effect. That's how observational research is done. Or, I'm gonna give you another observational. I used to work for a consulting firm, and at the end of the week, I have to meet with the owners of the company, or the president of the company, the board of directors, depending on how big it is, and I have to let them know why they're not maximizing profit. I was an analyst for a consulting firm, and I would come in I'd fly out Sunday night, I'd show up Monday morning at their business, they put me in a conference room, I'd start going over their financials, I'm looking to see if there's any difference in expenses, see if there's anything out of line, to try to pinpoint. They had me come in, they contacted the consulting firm to have one of the analysts show up, I'm flying in, because they're not making maximum profit. In many cases, they're losing money, that's why they're bringing us in. My job was to analyze the business and figure out why they're losing money, or why they're not maximizing profit, and then give my report at the end of the week. Part of my report was I had to do observational study. I had these questionnaires that I'd hand out to all the hourly employees, because most of these companies were manufacturing companies, so there's a lot of hourly employees, and this questionnaire would go out to them, because one of the things I always wanted to measure was hourly employees' attitudes. Because if you have a group of employees who are just hating their work environment, and it shows up in these surveys, that can hurt profit. The productivity goes down so much that it can hurt profit. And so that's one of the areas, and I use what's called observational multiple choice questions in a survey to collect that data to try to figure out what the overall atmosphere of the employees' attitudes are, whether they're motivated to be there or not, or if they absolutely hate their jobs. And it helps management to learn these things. Go ahead.
What was the example of the first one?
The first one was experimental. Let's say you had a group that's taken a drug and a group that's taken a fake drug, and you're trying to see if there's a difference in the results from taking that drug between the groups. That's experimental. And then this one's observational, handing out a survey, collecting the survey and seeing if things are normal, or did the results turn out way off to the edge. Like they're a lot of, let's say a lot of the answers were ones and ones because they hate their job or they hate the environment, whatever the questions are asking for. All right, so on this one, if this were on a quiz, it would be asking you, it would probably describe a data collection process, asking you, is that an experimental study being done or an observational study being done? All right, so there's that. Let's go now to, we're going to chapter 2 PowerPoint. These are pretty easy. Where's number 9? This is a bar graph. I know you all have learned way back when how to make a bar graph. This is all about, for this class, I just need to make sure you can read the bar graph. So if I said to you, hey, real quick, by the way, this is related to, remember this? We are at this hotel, we asked our how many guests? 20 guests to answer the question about their stay. Look at the options they had: poor, below average, average, above average, and excellent. There were the options, 5 different choices. Remember this? So now I go to this bar graph and I say to you, which answer was most common among those that were surveyed according to this bar graph? What was the response most common? Above average, very good. Okay, now let's look at this pie chart. The hardest thing about making a pie chart is figuring out how much of that circle you got to use. And I do want to tell you, it's you would put 360 degrees. You would know, put a 12 o'clock, put a 3 o'clock, put a 6 o'clock, put a 9 o'clock. I always start there, and then I take 360 and divide by how many sections is that? 4. So I know what those numbers are out of 360, and then I insert some other numbers. It's not that easy to make a pie chart, if you're doing it by hand. But here it is. Let's say you want to represent 25%. So 25% times 360 would be 90. So 90 would be straight down and straight, like 12 o'clock, 3 o'clock, a whole corner of the pie. And if you look at the pie, which one's 25%? Which one represents 25% up there? Average. And look how it's exactly a straight line and a straight line, 1/4 of the pie. So my question on the test, if this is on there, is if you can read the pie chart, not make it. And it'll be more like, what was the least common response according to this pie chart from the respondents?
Excellent.
Excellent, very good. Okay, so we got bar graph, pie chart. Oh, I almost forgot. Look at pie chart again. Look, I mean bar graph. There's bar graph. Look at it. Look at how it's made. Now hang on. Here we go. This is called a histogram. It's almost just like a bar chart, but the histogram really represents continuous data. What do you see that's observed differently about it than the bar chart? Yeah, the spaces between the bars. Notice there's no spaces. No spaces. Right there. That's called a histogram. That's the easiest way to recognize it. A histogram has no spaces between the bars. Everybody with me? Okay. Now we're going to. This is called a dot plot. I'm not asking you to make it. They're really easy to make, but I'm asking you to be able to read it. And the most common reason a dot plot's made when you have 1,000 pieces of data, because it makes it much easier to then recognize the mode. If I were to ask you, according to this dot plot, what's the mode of this data? What would you say? Estimate what the answer is. It's hard to read, but which one? 62 maybe, 61, I can't tell what that is. But you see it's the tallest dots, because each dot represents a number piece of data of that particular data. So you're looking for the tallest one to find the mode, and it happens to be 61, 62. Can everybody find the mode now from a dot plot? Can there be more than one mode?
Yes.
And what would it be called if there's two modes? Bimodal, very good. What if there's more than two modes? Multimodal, very good. I forgot to put those up there. Those are more terms we learned. All right, that's all I got. Let me just make sure. Anybody who didn't get back their in-class assignment that I handed back, please come up here and get your assignment. Anybody, that's it. I'll see you on Thursday. Yeah.
So the thing you did about the quality rating and all that, was that a observational?
You know, I called it observational, but it's almost experimental, isn't it?
That's what I was thinking.
Yeah, you know, I may have mispronounced, I may have said excellent observation, and maybe.
Okay.
It's a before after. It's called a before after. And a lot of managers do that, because they want to get money for it. Yeah, but you can get 75 of those points back for anything that's missing, which would include those results.